Welcome back to Maths with Mrs. J. We've been talking about functions and about domain and range. It's relatively easy to determine the domain and range if you're given the graph of the function or the relation. It's a little bit more tricky when you're just given the function rule. I'm going to teach you how to determine the domain and range from the function rule. Sometimes that still is a good idea to get a little sketch happening, just a very rough one, so that you can see what's going on, and that will help you. Generally speaking, most of the functions that you would have already met will have a domain of the real numbers, all right? Linear functions, quadratic functions, any polynomial function, unless there is a good reason for it to not be applicable for all real values of x, such as maybe x is representing the length, then we can assume that it's okay for all real values of x. The range will depend a bit on what the sort of function is. If you have a parabola, then obviously it's either going to have a local minimum or a local maximum, and that will determine your range. Functions other than polynomials, the sorts of limitations you need to be looking for are things like square roots. Anything under a square root sign must be at least 0, greater than or equal to 0. A rational function, the denominator cannot be 0. Also look out for horizontal asymptotes if you have a rational function. Know your basic features of your trig functions, your log and exponential functions, etc. Circles, of course, they're not functions, but they are important relations that do come up from time to time. Know what they look like roughly, what the various changes to the formula will make to your domain and your range. Let's go ahead and do some actual examples. So we have some functions here where we're given the rule and we need to work out what the domain and range are, the maximum domain and range. So unless we're given anything to the contrary, we'll assume that we're allowed to have the maximum domain and range. The first one is just a linear function, isn't it? It's a straight line. There is no reason whatsoever why that is not defined for all real values of x. So the domain would just be the set of real numbers. Similarly, because it's a straight line, it's going to be going up from left to right across the page. All real values of y will come into play as well. So the range will be R also. Question 2, f of x is a quadratic function. It will graph as a parabola. This one you should know is going to graph as a parabola that is concave down and it's been shifted up by 5. All real values of x for the domain are still in play, but you'll notice that your range, the maximum value of your y will be 5. There are various ways you can write that. You could write it, if you like, as from negative infinity up to 5 and including the 5. Of course, you can't include negative infinity because you can never actually equal negative infinity. You could write it as y is an element of the real number system such that y is less than or equal to 5. It's really up to you exactly how you want to write that, but either of those would be fine. All right, question 3, g of x is 1 over x plus 4. Again, having some basic knowledge of what this looks like, even though you're not given the graph and even though you're not required to draw a beautiful looking graph, just having an idea in your head of what's happening here is a good idea. This is a hyperbola that has been shifted 4 to the left. So, and clearly we can see here, if x is negative 4, that denominator would be 0. That would make this function not defined. So your domain here is going to be all real numbers except for negative 4. Similarly, our range, we should know that we have a horizontal asymptote there along the y-axis. So your range will be all real numbers except for 0. Again, if you wanted to do a little sketch of that, you can. You've got your asymptote coming through here. We've got that kind of situation happening. This one here, okay, again, let's think about, we've got a rational function. We cannot have that denominator equaling 0. Everywhere else it should be fine. So your domain would be all reals except negative 2. Now let's just think about this for a minute. What's going to happen? What would this function look like? This numerator, if you expand it out, would be x minus 2, x plus 2. So this function is actually going to be the same as the straight line y equals x minus 2, except for that little open circle when x is negative 2. So what would the y value be if you could sub in negative 2 there? Well, negative 2 minus 2 is negative 4. So your range here is actually going to be every value in the real number system except for negative 4. This will be a straight line, x minus 2, but you're going to have an open circle at x equals negative 2, and that will correspond to y equals negative 4. All right, question 5, we have a square root. Anything under that square root must be at bare minimum 0. It has to be greater than or equal to 0. So our domain, x minus 4, is going to be greater than or equal to 0, so x is going to be greater than or equal to 4. How you write that is up to you. You can write x as an element of the real numbers such that x is greater than or equal to 4. You could write from 4 to infinity, and of course we can't include infinity. Your range, now again, we need to be careful here. If you have the square root sign, that means the positive square root. So the minimum value here is going to be 0 for your y's. So we could do this. We could say y is an element of the real number system such that y is greater than or equal to 0. Or you could say from 0 to infinity. It doesn't really matter exactly what terminology you use, as long as it's mathematically correct and is the correct domain and range, that's fine. This next one here, it's helpful to know that no matter what you're taking sign of, the sign function is always going to be between negative 1 and positive 1. So even though that's got an x squared there, sign will always be between negative 3 and positive 3. Because we're multiplying it by 3. So there's no reason why we can't have any real number for our domain, but our range is going to be between negative 3 and positive 3. This will have an amplitude of 3. So we could write that like this. So we're including both sides. We could write it like this. So, y is between negative 3 and positive 3. No reason why any real numbers of x can't be used there. Just bear in mind we're talking about radians when we're doing these sorts of things in our trig. Final one, again, have a basic knowledge of what y equals 2 to the x looks like. Y equals 2 to the x, going to look like that, going through 1. If it's had 3 subtracted, it's going to be moved down and will go through here. That kind of thing. So again, the domain is just going to be the set of real numbers. There's no reason why you can't have any real number there. The range, what's going to actually happen here, normally there's an asymptote here and the graph approaches 0 from above as you tend towards negative infinity. This time, because it's being shifted down by 3, the y value will be approaching negative 3 from above. So all your y values are going to be greater than negative 3. So we're not going to include the negative 3. It's never going to actually touch negative 3. So we could write it like that. We could write it like this. Something like that. Now we've already sort of touched on limits a little bit there. We've been talking about as x is tending towards infinity and that sort of thing. That will stand us in good stead for the next series of videos on limits and continuity. So just bear that in mind.